Okay, we're going to solve these inequalities. So let's start off with the first one, part A, up here. So I'm going to go 3 open brackets 2x plus 1 is greater than 5 minus 2x. Well, let's remove the brackets first. 3 times 2 gives us 6x plus 3 is greater than 5 minus 2x. Get all the x's on the same side, so add 2x to both sides. I get 8x plus 3 is greater than 5. Minus 3 from both sides, I'll get 8x is greater than 2. And then divide throughout by 8, I get x is greater than a quarter. So that's part A done. Let's do part B. All nice and easy, that. Do remember though, if you're doing inequalities, if you divide or times by a negative number, the symbol in the middle, this symbol here, will flip. It'll end up turning the other way around. Yeah, so it'll end up being that way around if you times or divide by a negative number. Important to remember that, but not applicable in this question. Next, we're going to try and look at what range of values x has for this inequality. And we're going to try and see if we can factorise. I think I can see how we can do that nicely. If you think about it, we've got 3 and 1 are the only factors of this, and 2 and 1 are the only factors of this. How are we going to combine them to get 7? Well, 2 times 3 is 6, and 1 times 1, let's just write those factors out so you can see them. So if we did 2 times 3 is 6, and 1 times 1 is 1, and you get 7 if you combine them. Now we want to get minus 7. Well, you could get minus 3 and minus 1, therefore times together to give you 3, and then you can combine these to get your 7. So let's put that into bracketed form. So we've got 2 lots of x here, and we've got 1 lot of x. Now we want to combine the 2 with the minus 3, so put the minus 3 the other side, and put the minus 1 this side. Always do a little check in your head to make sure it works. Minus 1 times x, 2x times minus 3 is minus 6x, so you get minus 6x gives us minus 7x. So that does work, and then you times these two together to get that, times these together to get that, and you've got the ideal solution. Now what I always reckon you should do is look at where x equals 0. So this one gives us a critical value of 2x minus 1 equals 0. So therefore, let's just write out that as a side piece of working. So let's look at 2x minus 1 equals 0. That gives us 2x equals 1, and therefore x equals a half. So half can be one critical value. And then this one's going to give us 0 when x is 3. So let's have a look at what the curve will produce if we were to draw this expression as a curve. Alright, and we've got solutions. Sorry, it's not great looking axes. We've got solutions at a half, and we've got solutions at 3 when this equals 0. Those are our boundary values to our problem. Now, where are we going to have it greater than 0? Well, this whole expression will equal greater than 0. This is, I've effectively drawn y equals this. This is where y is greater than 0, so above here. So this bit here and this bit here will be where it's greater than 0. So therefore I want to be that side of 3 and that side of a half. So I want x to be greater than 3, or I want x to be less than a half. Now I want to combine these answers here in part C with this answer for part A. So I want to know where will I be satisfying both equations. Well, I can only the x less than a half is not going to be satisfied once we get below a quarter, because we need to satisfy as bigger than a quarter. So we got these boundary values of a quarter, of a half, and of 3. This is part C we're doing. We know we need to be bigger than a quarter, so we know x has got to be bigger than a quarter. We know that x needs to also be less than a half. Okay, and also that x can be greater than 3, because greater than 3 is also bigger than a quarter. Is there a way that we can show that graphic? Let's draw the number line. to show this. And we put in our critical values, quarter, a half, and 3. Now let's just put this solution up here, highlight in blue. So greater than a quarter is all the blue bit. Okay, let's make that nice and big so we can see our overlaps more easily when I come on to put the next bit. Okay, now this solution only happened when I was less than a half. I've made it so big. Oh no, it's okay. It's going to overwrite it, isn't it? So there we go, less than a half, and also when it was bigger than 3. Now, where do both of these happen? Let's pick another highlighter to show where these both happen. Well, they both happen here. Okay, and they both happen here. And you can see that agrees with our expression there, and that agrees with our expression there. I forgot to write in my x here. Wouldn't be a perfect answer without that x in there. So there we go. That is how we can combine the two to get us our final answer.